So in this lesson, I'm going to show you how to solve equations involving powers. So we'll begin with question A. We have 2 to the power of x plus 3 is equal to 4 to the power of x. So we can see that we have a base of 2 on the left-hand side and a base of 4 on the right-hand side. And to solve this equation, we need the two bases to be the same. But we can write the 4 as 2 squared. So on the left-hand side, we have 2 to the power of x plus 3. And on the right-hand side, we can write this 4 as 2 squared, which we're raising to the power of x. So now we can use the power rule to multiply the 2 and the x together. So we have 2 to the power of x plus 3 is equal to 2 to the power of 2x. So now, because the equation is equal and the bases are the same, these two powers must also be the same. So we can say x plus 3 is equal to 2x, or this power is the same as this power. So now we can solve this equation by taking away x from both sides. These two will cancel, so we're left with 3 is equal to 2x minus x, which is just x. And we can check that this works by substituting this 3 back into our original equation. So we have 2 to the power of 3 plus 3, which is 6, and this is 64. And 4 to the power of 3 is 4 cubed, which is also 64. So we know that x is equal to 3. Okay, so do you want to try question B? You can pause the video, and when you come back, we'll go through the work solution. Okay, so welcome back if you had a go. So the first thing we need to do is to write the bases 4 and 8 with the same base, and they can both be written with 2 raised to a power. So this 4 is the same as 2 squared, which we're raising to a power of x plus 1. And this 8 is 2 cubed, which we're raising to a power of x. And again, we can use the power rule where we multiply the 2 by the x plus 1. So we have 2 lots of 2x plus 2. And this is equal to the 3 multiplied by the x. So 2 to the power of 3x. So now we can make the powers equal because the bases are the same. So 2x plus 2 is equal to 3x. We can solve this equation by taking 2x from both sides. These will cancel. So we're left with 2 is equal to x. And this is our solution. Okay, so moving on to question C. Now we have 1 over 3, or 1/3 raised to the power of x. We'll just block this off. Is equal to 3 to the power of x plus 4. Now we can write this 1/3 using index notation. Because it is 1 divided by 3, this is the same as 3 to the power of negative 1, where this negative means 1 over, and the 1 is the 1 here, which is what 3 is raised to a power of. Don't confuse this 1 with this 1. The 1 over means the negative power. And now we're raising this to the power of x, which is this x here. And this is equal to 3 to the power of x plus 4. So now we can use the power rule. We have 3 to the power of negative x is equal to 3 to the power of x plus 4. We can equate the two powers. So negative x is equal to x plus 4. So we can add x to both sides. These will cancel. So we have 0 is equal to 2x plus 4. We'll take away the 4 from both sides. These will cancel. So we're left with x is equal to negative 2. Okay, so do you want to try question D yourself? You can pause the video, and when you come back, we'll go through the work solution. Okay, so welcome back if you had a go. So the first thing we're going to do is write this 1/5 using index notation. So this becomes 5 to the power of negative 1, which we're raising to a power of x plus 1. And the 25 is 5 squared, which we're raising to a power of 2x. So now we can use the power rule. We'll multiply the negative 1 by the x plus 1. So we get 5 to a power of negative x plus 1 is equal. We'll multiply the 2 by the 2x. So 5 to the power of 4x. And now we can equate the two powers. So negative x plus 1 is equal to 4x. We'll expand out the brackets. So negative x minus 1. And then we'll add x to both sides. So these will cancel. So negative 1 is equal to 5x. And finally, we'll divide both sides by 5. These will cancel. So we're left with x is equal to negative 1/5. Okay, thank you very much for watching, and I hope you found that useful. Thanks again, and take care.